Let's take a look at the addition method, which is problem number 17. And let's see, solve it by addition. Some books call this elimination. So it's just different books do different things in that regard. And going through our steps. Multiply. I put this for the first time in words the other day, and so this is like version 1.1. Multiply one or both equations by a number such that either, actually, I'm lying to you, line up the like terms in the same columns. And step 2, multiply one or both of the equations by a number. I'll put an S here to indicate they can be different numbers, such that either the x's or y's are additive inverses of each other. Now, to refresh your memory on additive inverse, for an additive inverse, examples of that are like 5x and negative 5x. So they're exactly the same, except for one's positive, one's negative. Then add the equations. Then solve. And then step 5, plug the value you just found into one of the equations and solve for the other variable. Okay, plug the value you just found into one of the equations and solve for the other variable. So let's see this one in action. Number 17. 4x minus 3y equals 5. 3x minus 2y is equal to 4. Line up the like terms in the same columns. Well, the x's are lined up here, the y's are lined up, and the numbers are lined up. So that's good. Step 1 is done. Step 2, multiply one or both of the equations by a number such that either the x's or y's are additive inverses of each other. I'm going to choose the y's to work with. And additive inverse means that this one would be negative 3y and this one would be positive 3y. Now you want to pick numbers that are easy to work with, and probably the easiest is multiply times the other number. Like this one here, I'll multiply this by 3. And in this equation, I'll multiply it by the other number. I'm looking at my y's. I'd multiply it by 2. So again, I decided to eliminate the y's. And I look at this, and for my second equation, I multiply it by 3. And for my first equation, I look at the other number, and I multiply it by 2. Now, to be additive inverses, they have to be different signs. See how these are both negatives? So one of these has to be a negative. So I'll make that one a negative. So, negative 2 times 4x gives us negative 8x. Negative 2 times negative 3y gives us a positive 6y. And negative 2 times 5 gives us negative 10. Now we'll multiply the second equation by 3. 3 times 3x is 9x. 3 times negative 2y gives us negative 6y. And 3 times 4 gives us 12. Now you'll know you did it correctly if they are actually additive inverses of each other at this point. Now, I picked negative 2 and 3, but there's an infinite number of possibilities you could choose. This is probably the smallest one. Key is they just got to be the same except for the sign in front. Okay, step 3. Add the equations. So we're going to add the individual columns. Negative 8x plus 9x gives us 1x or x. 6y minus 6y drops away. And negative 10 plus 12 gives us 2. Now you know you've done it correctly is if one of the variables disappears completely. See how the y's disappeared completely? Now step 4 says solve. Well, this one's pretty boring. There's nothing really to solve. It's already solved for x, so x is equal to 2. Step 5, plug the value you just found in one of the equations and solve for the other variable. It doesn't matter which one you pick. It'll work in either one. Pick whichever one looks easiest to you. I'll pick the first one. 4x minus 3y equals 5. And we just said x is equal to 2, so put 2 in for the x. 4 times 2 gives us 8, minus 3y equals 5. Take the 8 to the right side, becomes a negative 8. 5 minus 8 gives us negative 3. Now divide both sides by negative 3. And we get y is equal to 1. Our answer is usually written in point form, so put 2, 1. And that's our ordered pair, our answer, 2, 1. 2, 1 would be C. So let's check that, 17C. 17C, and that's our answer.